Acephysics.org, Math and Physics Tutoring with Dr. Hudis.
I'm now going to show you one of my statistical mechanics midterms. This class was taught by a professor who gave a lot of work. He set high standards for his students and was notorious for giving exams that were long and had long, challenging calculations. I learned a lot from both of his classes, so I'm not complaining. You can't complain when you learn a lot from a professor. But the tests were long and difficult, and so were the homework assignments. So I'll read through the problems, and then I'll show you my work. Problem 1 says, electromagnetic radiation at a temperature Ti fills a cavity of volume V. If the volume of the thermally insulated cavity is expanded quasi-statically to a volume 7V, what is the final temperature Tf? So that was problem 1, and that was similar to a homework problem, so it was reasonable to put on a test. Problem 2 was very different than any of the homework problems because it was a mixture of both fermions and bosons. I don't want to say it was unreasonable to put on a test, but the class average was low, so it's debatable. But I did learn a lot from the test and from this class, so like I said, I'm not complaining. So problem 2 says, consider a gaseous mixture of helium-4 and helium-3 atoms, of which there are N1 and N2 combined to a volume V. Assume that there is no interaction among the atoms, i.e. the gas is ideal. Part A. Write down but do not evaluate the expression for the Helmholtz free energy of the system, which would hold for any temperature and at any large N1 and N2. Part B. Taking the classical non-degenerate limit, determine the expression for the entropy of the mixture in terms of N1, N2, Vt, the masses of the two individual atoms, and the fundamental constants of nature. C. Still in the classical limit, find the pressure such a mixture exerts on the walls of a container. D. Determine the temperature dependence of the low temperature specific heat, i.e. the degenerate limit. So that was the test. Okay, so now I'll show you my work for this exam.
Hi, I'm Dr. Jacob Hudis, and I offer online AP Physics test prep classes. I offer 2 classes for AP Physics C, one for mechanics and one for electricity and magnetism. I also offer 2 classes for the Algebra AP Physics test 1 and 2. Please go to my website, acephysics.org, to find out more.
As you can see, I got a 77%, which worked out to be an A. The class average was a 45%. I got the second highest score, but the highest score was 100, so I don't know if I should be happy I got the second highest score or disappointed I did so much worse. I also remember that there was a very long homework assignment that was due on the day of this exam, and everyone in the class studied like crazy for this test. I think I studied for about 20 hours. Anyhow, so here's my work. So this is problem 1, the first page of problem 1, and here is the second page of problem 1. And problem 1 was similar to a homework assignment, so I got that one correct. And then problem 2 was different than anything we'd seen on the homework, and it was a long problem. So here's my first page for problem 2, I'm sorry. Here is the second page for problem 2. And as you can see, there's a lot of long integrals, and if you make mistakes on the integrals, you'll obviously lose several points. Here is the third page for problem 2. Here is page number 4, although I call it 3A for problem 2. Here is the 5th page for problem 2. Here is page number 6 for problem 2. Problem 2, page number 7. And I think problem 2, page number 8. So that is an example of a statistical mechanics midterm in physics graduate school. Alright, so here's another statistical mechanics homework assignment, and as you can see, this was only one problem, and that's misleading because this was actually one of the hardest, if not the hardest, assignment of the whole year, for this class at least. And so this says, consider a 2D non-relativistic gas of non-interacting charge E fermions moving in the xy plane with the dispersion E of k equals h bar squared k squared over 2m. The fermions are subject to a uniform magnetic field B perpendicular to the xy plane. Assume that the chemical potential is fixed and that it is much larger than h bar omega c. Part A. Calculate the grand canonical potential using the Poisson summation formula. Leave your answer in terms of the sum over harmonics without evaluating the sum explicitly. Part B. Find the non-oscillatory component of the constant area specific heat at low temperature. Part C. Find the expression for the lowest harmonic of the oscillatory component of the constant specific heat. Plot the amplitude as a function of the dimensionless ratio kBt over h bar omega. So that was one problem, and I remember I was very stressed out doing this homework assignment, and so were many other people. And I don't even know how long this took. I just remember working on the chalkboard and just working on these integrals and doing them for a long, long time, figuring out how all this works. And